I'll go over two ways you can find the volume of a spherical cap. So what a spherical cap is that if you have a sphere, so here we have a sphere, and a spherical cap means if I just take a plane, or if I take something and I slice it across, right, straight, right, then I get this cap. So this is a spherical cap. So this is like if I am looking at the sphere directly, face forward, but usually it's from the perspective of if you're looking at it a bit more from the top, it looks something like that, okay? So this is a spherical cap, okay? So I'm trying to find this volume right over here. Let me see if I could rotate this. I cannot. So the way I will find this, the volume right over here, okay, this volume, is that using calculus 1 techniques, calculus 2 techniques, integral calculus, we can use solid of revolution. So what we can do here is that if you take, let's say if you take this circle with radius r, so this is my y-axis, this is my x-axis. So this circle would have equation x squared plus y squared is equal to r squared, which means y, I'm only going to look at this top portion right over here. So this top portion over here. Okay, this top portion over here. So this would have equation y is equal to r squared minus x squared square root, and it will be just positive square root. Okay. The negative, I put a negative here, it will be the bottom one. Okay. So what if I have a spherical cap, or the cap has height h? So this is h. So that means if the radius is r, that means this will be r. Okay, so from here to here is r. So this would have a value of r being positive. Okay, this would be like minus r, right? And this would be r. This would be minus r. That means if this little section is h, what is this distance right over here? Well, it's just r minus h. Okay. So then what we can do is that we can take this region right over here and do solid of revolution. So take this region and apply solid of revolution. So I rotate that region, right, around the x-axis, and I should get my cap, right? I get the volume like that. Okay, so now to do that, we'll take the integral of pi from a to b, integral a to b pi f of x, whole thing squared dx. Our lower bound here is going to be, what is it, r minus h, and then my upper bound b is going to be r. Pi is a constant, I'll just take it out, and then f of x is just a y value, which is the square root of r squared minus x squared, but this whole thing is squared. Okay, this whole thing is squared, dx. Here, the square, when you're square rooting and then you're squaring, so they cancel out. And you're left with this. Okay. Just be careful that when you square first and then you square root, this is absolute value of x. And then if you square root first and then you square it, this is equal to x, but x has to be greater than or equal to 0. Okay. But yeah, we see here that indeed r squared is greater than or equal to, r squared minus x squared is greater than or equal to 0. okay? Because in order for this to work underneath the square root, this has to be true. That we get that r is between, or I should say x is between r and negative r when this is true, okay? Okay, so anywho, that was a bit of a tangent. So if you integrate this, you get pi, and if I integrate r squared as a constant, so r squared x minus x cubed over 3, integrate from r minus h to r. So I'm going to move this over here, plug it in. So first part is going to be r squared times r is r cubed minus r cubed over 3. Now minus r squared times r minus h. And then we have negative, negative, so that becomes positive. Okay, r minus h cubed divided by 3. Because technically it should be like that. Right, this is like f of b, or f of r minus f of r minus h. Okay, but here this negative you can distribute. So this negative distributes with that, that becomes positive. So now this becomes positive. Can we simplify anything? Let's see, this is equal to pi. So r cubed minus r cubed over 3, that's 2/3 r cubed, or 2r cubed over 3, minus, what I'm going to do here is I'm going to, from these two, I'm going to factor out an r minus h. So factor out r minus h. I'm left with, actually, no, instead of doing that, I will, I'll have to expand out this. So I get r cubed plus h, plus, I should say plus rh, and then plus, oh, there should be minus. Oh, no, there should be plus. Double negatives. Negative, negative, yeah. So plus r squared h, right over here. And then I have to expand out r minus h cubed. You can say it's just r minus h, and then r minus h squared over 3. But we know r minus h squared is r squared minus 2rh plus h squared. Okay. And then distributing, actually if I combine these, this will be minus r cubed over 3 plus r squared h, plus distributing this, I should get r cubed minus 3 r squared h, and then it should be so minus, so I have minus 3r squared h, and then I think this is minus 3rh squared, no, plus 3rh squared, okay, because negative, and this becomes, yeah, I have this times that's 2rh squared, and then plus rh squared, yeah, 3rh squared, yeah, and then I'll have, yeah, minus 3r squared h, because I get minus 2r squared h, and then I get minus hr squared, or minus r squared h, which is negative 3r squared h. Okay, and then I have negative h cubed. Okay, all of this is over 3. So all of this is over 3, which means that each of these is going to be divided by 3. So this is going to equal pi minus r cubed over 3 plus r squared h plus r cubed divided by 3 minus r squared h plus r h squared minus h cubed divided by 3. We see here that the negative r cubed h and the negative r cubed over 3 and the positive r cubed over 3 cancel out. R squared h and the negative r squared h cancel out. So I am just left with pi times r h squared minus h cubed divided by 3. And then if I factor out the h squared, if I factor out h squared over 3, so pi h squared over 3, then this would be 3r minus h. Okay. Yeah. Because factoring out the 1/3, essentially you're just dividing out the 1/3 inside here. So then, yeah, this should be it. Cool. So yeah, pi h squared over 3 times bracket 3r minus h. Okay, so this is one of the ways to find the volume of a spherical cap. Okay, so it's not too bad if we use the Calc 2 integral calculus techniques for volume / solid of revolution. Now, the next part, I will go over how to do this using calculus 3 methods, polar coordinates. Okay, so this is going to be a bit long. So here's the next part. So this is the formula. Okay, so pi h squared over 3 times 3r minus h. So now using calculus 3 methods now, let's orient our sphere. So I'm going to take this and copy and paste it. Okay, so then I'm actually going to erase all of this. Okay. So now this is my z-axis, this is my y-axis, and then here's my x-axis now. Again, I'll have my little cap right over here. I'm trying to draw this a bit better. Okay, I'll just do it like this. Okay, and then this cap would have, so a sphere with radius r. So this is x squared plus y squared plus z squared is equal to r squared. This height is r. This height right over here is going to be, so if this is h, again, if this is h, then this height is going to be r minus h. So now, this implies from here we get that z is equal to r squared minus x squared minus y squared square root. So now this again will give you actually the top semicircle, okay, with radius r. So r here, r here, r here. Okay. But now what we really want to do is we want to use cylindrical coordinates. Okay, so how would we use cylindrical coordinates? Notice that for cylindrical coordinates, my z values is actually going from, so using cylindrical coordinates, x squared plus y squared is equal to r squared. So I'm subtracting r squared over here, okay? Because x is equal to r cosine theta, y is equal to r sine of theta. Theta goes between 0 and 2 pi. R goes between 0 and an upper bound, which I'll find later. But Z will go, is dependent on R. Z will go from R minus H, because if I were to project this, the domain for just this spherical cap, it is essentially just this circle, right? It's this circle right over here. If I project it onto the xy plane, it'll look like that. Okay, and there's a circle with some radius. Okay, so the radius will go from 0 to the outermost radius, which I'll find later. But we see here that Z will always go from this height to whatever this is, the top of the cap, which is defined by this one right over here. So it's always starting at r minus h, which is this height, and it's going from r minus h up to the top of the cap, which is the square root of r squared minus little r squared. Okay. So now, if I want my z, if my z is r minus h, what is x squared plus y squared? What is the radius for x squared plus y squared? What is the upper bound for my radius? So I know that x squared plus y squared is equal to r squared minus z squared, which is equal to r squared minus, now what is the radius for this red circle when z is r minus h? So z is r minus h squared. So when z is r minus h, plug in here, I get that. So we see here that this is my upper bound, right? This is my new, call it like r bar squared, okay? Now, my radius is going from 0 to r bar. So this radius right here would have a radius of r bar. So from here to here is also r bar. So we'll go from r bar, 0 to r bar. So 0 less than or equal to r, less than or equal to, what's r bar? R bar is just the square root of r squared minus r minus h squared. And this is true because r minus h is smaller than r, so r squared, and these are all positive values, right? So r and h, they're both positive, r minus h. H is smaller than r, so r minus h is also positive, but it's smaller than r, so r squared minus r minus h squared is positive. So this all works out well. Okay, and then what you have to do is just plug and chug into that volume formula. Volume is equal to the triple integral over this particular region, right over here, dv, right? Now what's dv in terms of cylindrical coordinates? So dv is equal to r dr d theta dz. Okay, we see here that z is dependent on r though, so we should probably put dz first and then dr. And then I usually just put d theta last because theta is not dependent on anything, right? Theta is just going from 0 to 2 pi. Now z would go from r minus h to z is equal to the square root of r squared, capital R squared minus little r squared. And then r will go from 0 to, I'm not going to write this out, but I'm just going to call this whole thing r bar. That's r bar, okay? So now this is equal to notice that with this theta, I can just integrate the theta, so it would just be 2 pi, okay, because r and z, they're all constants with respect to theta, so once we evaluate what this is, right, all of this is a constant with respect to theta, so it can pretty much just be taken out, right, because there's no theta here, right? So once we do this evaluation, you're just going to get a number. So this is a number, what's inside the square bracket, or what's inside these brackets, right? It's a number, so you just take it out. So you're just left with 0 to 2 pi d theta, which is 2 pi minus 0, so it's just 2 pi, okay? And then we have the integral from 0 to r bar, and then r minus h square root of r squared minus r squared, and then r dz dr. Now notice that this r over here is a constant with respect to z, so you could just take it out, right, of that z integral. So then this is equal to 2 pi integral r to r bar, 0 to r bar of r, and then it's going to be the square root of r squared minus r squared minus, and then r, and then plus h, because minus negative h. So this is what I have, dr. Okay, now the reason why, and this is pretty good, because if I were to just evaluate this integral over here, it's just z, and you're evaluating from r minus h to square root of r squared minus r squared. So it's just going to be this minus that, which is what we have over there. Okay, now I can do a u substitution. Let u equal to, let's say, r squared minus r squared. Then du is equal to negative 2r dr. What does this imply? It implies that r dr is equal to negative 1/2 du. Okay, so this is equal to 2 pi, and let's see, r equals to 0 maps to u is equal to, so u equals to r squared, and when r equals to r bar, that will map to u is equal to r squared minus r bar squared. Okay, so then I'll just change this to be, so u goes from r squared to r squared minus r bar squared. So r dr is negative 1/2 du, and then I have what's inside the brackets, which is the square root of r squared minus r squared, which we said was u, and then minus r plus h. Okay, we see here that r squared minus r bar squared is actually going to be smaller than r squared, right? R bar squared is positive, but r bar is smaller than capital R, so r squared minus r bar squared is going to be smaller than r squared, but that's okay because we have a negative sign right here, which means the limits of integration are flipped, which is good, because here this is the lower limit is actually bigger than the upper limit right over here. With the negative sign, we flip it. Okay, so we have r squared minus r bar squared to r squared, and it's going to be positive 1/2. You take this positive 1/2 out, it's going to cancel out with this 2. So these will cancel out. And then we just have the square root of u, and then I'm going to do plus, I'm going to do this. I'm going to do plus h minus r. Plus h minus r. Okay. Du. Okay. So now this is equal to pi. So now if I were to integrate the square root of u, integral square root of u, so u to the 1/2, you just add 1 to the exponent, so it's going to be u to the 3/2 divided by 3/2, which is the same thing as multiplying by 2/3, and then plus h minus r is a constant, so I'll group them together. H minus ru. U goes from r squared minus r bar squared to r squared. Wowzers. Okay, so what is this going to be? This is going to equal to pi multiplied by 2/3, so r squared square root, so it's just r cubed, right? Yeah, so r squared to the 3/2, which would be r to the 3, so, and then plus h minus r times r squared. So now what we need to do, we need to subtract 2 over 3 r squared minus r bar squared, and then subtract, distribute the negative, subtract h minus r, and then my u here is going to be r squared minus r bar squared. Okay, wow, what a nasty thing, right? So this is going to be pi. So this is going to be 2 over 3 r cubed plus, I could do hr squared minus r cubed, okay, and then minus 2 over, there should be a, I think I messed up somewhere. There should be exponent 3 over 2 here, okay? So now let's just see, so I just stop right here, so minus, that corresponds with that minus sign. What is r squared minus r bar squared? So r squared minus r bar squared is equal to r squared minus, what's r bar squared? R bar squared is this. So it will be minus r squared minus r minus h squared. We see here that this is just equal to r minus h squared. Okay, so because the r squares cancel out and negative becomes positive, r minus h whole thing squared. Okay, so I have minus 2 over 3 r squared minus r bar squared is just this. So if I'm raising this to the 3 over 2, then all I have is just r minus h to the power of 3, and minus h minus r, and then again r squared, capital R squared minus r bar squared is just all of that. So it will be r minus h squared. All right, so right over here, actually, you can actually factor out a negative from here. Then you get r minus h, right? But then this will be positive, okay? So then I'm just going to do that. So this right over here is actually positive. R, factor out the negative becomes r minus h. And the reason why I did that is so that it can combine with this r minus h. So in the end, I get pi. So what I have is, so 2 over 3 r cubed minus r cubed is going to be negative r cubed over 3. And then I have plus h r squared. And then minus 2 over 3. What was r minus h cubed again? It was r cubed minus 3 r squared h plus, what is it? Plus 3 r h squared, and then minus h cubed, okay? And then this is going to be plus, or actually, hold on. Before I even expand this, let me do this. So I still have the r minus h cubed minus, so oh sorry, this becomes a plus now, plus r minus h cubed. And that is going to equal to pi multiplied by negative r cubed over 3 plus h r squared. So I have 1 r minus h cubed minus 2/3 r minus h cubed. So 1 minus 2/3 is 1/3, so I get plus 1/3 of r minus h cubed. So now this is equal to pi multiplied by, so minus r cubed over 3 plus h r squared plus, and then expand r minus h cubed is r cubed minus 3 r squared h plus 3 r h squared minus h cubed, everything over 3, Okay, so then this is equal to pi times negative r cubed over 3 plus h capital R squared plus r cubed divided by 3 minus r squared minus, what is this, r squared h, and then plus rh squared minus h cubed divided by 3. Let's see, again, the minus r cubed over 3 and the positive r cubed over 3 cancel out. The r squared h and the negative r squared h cancel out, so I'm just left with pi times rh squared minus h cubed divided by 3. Cool. If I factor out a h squared over 3, so this will be pi h squared over 3. Well, this will just be 3 r over here, okay? Because if I distribute the 1/3 into the 3, they cancel out to make 1. And then I have minus, and then minus h. Okay, so this formula right over here is the exact same as this formula over here. Okay, so in both cases, we get pi h squared over 3 times 3r minus h. Okay, so that is it. Very, very interesting indeed. So we see here that using the calculus 3 method with cylindrical coordinates is actually much longer than using calculus 1 integral calculus volume or solid of revolution.